This is video 3A for the Year 9 Mathematics course. In this video, we're going to be covering some example questions from Exponent Laws under the topic of exponents. The 8 questions we will be going through are now displayed on the screen, so I recommend that you attempt these questions before watching the rest of this video. Question 1. Simplify 2x to the power of 10 times 11x to the power of 7. Alright, so the expression that we have here is 2x to the power of 10 multiplied by 11x to the power of 7. So the first thing that we can do here is combine the two coefficients. So here we have 2 multiplied by 11, so we'll just write this off to the side, and then we can do the x's. So here we have x to the power of 10 multiplied by x to the power of 7. 2 by 11 is simply 22. And then we have x to the power of 10 times x to the power of 7. Because we are multiplying these bases, we are going to add the powers. So this will now be x to the power of 10 plus 7. And all this simplifies into 22 x to the power of 17. Question 2. Simplify 15x to the power of 22 over 9x to the power of 13. Okay, so here we are dealing with 15x to the power of 22 all over 9x to the power of 13. So, first thing that we're going to do here is split up the regular coefficients from the x terms. In terms of the regular coefficients, we have 15 over 9, so we'll write this one here off to the side. And then we have x to the power of 22 over x to the power of 13. First things first, 15 over 9 can get simplified down by dividing both the numerator and the denominator by 3, in which case we then get 5 over 3. And then, because we are dividing the bases of x, we are going to subtract the powers. So in other words, we're going to have x to the power of 22 minus 13. This here simplifies into 5 over 3 multiplied by x to the power of 9, or, in other words, you can also write this as 5x to the power of 9 all over 3. But either of these two forms for your answer is 100% fine. Question 3. Simplify x to the power of 4 to the power of 12. Okay, so here we have x to the power of 4 all being risen to the power of 12. Now, we of course know that when we have a power being risen to another power, all we need to do is multiply the two powers together. So in other words, here we have x to the power of 4 multiplied by 12, or in other words, x to the power of 48. Question 4. Simplify negative 2x all to the power of 3. Okay, so here we have negative 2x all being risen to the power of 3. Now we know that when we have a multiplication and a power, then we can just apply this power to everything inside of the multiplication. So in other words, we can instead rewrite this as negative 2 being risen to the power of 3 multiplied by x being risen to the power of 3. Negative 2 to the power of 3 is equivalent to negative 8, and then x to the power of 3 is simply x to the power of 3. So our final answer here is negative 8 x to the power of 3. Question 5. Simplify 5x squared over 3y to the power of 3, all being risen to the power of 3. Okay, so here we have 5x squared all over 3y to the power of 3, all being risen to the power of 3. Now, when it comes to a quotient being risen to a power, we know that we can apply this power to the numerator and to the denominator. So in other words, this is now going to get turned into 5x squared all to the power of 3, all divided by 3y to the power of 3, all being risen to the power of 3. And so what we now have are two products being risen to the power of 3. And we of course know that when we have a product being risen to a particular power, we just apply that power to everything inside of the product. So in other words, on the numerator, this power of 3 can get applied to the 5 and to the x squared, and on the denominator, we can apply the power of 3 to this 3 and the y cubed. Okay. On the numerator, we have 5 to the power of 3, which is equivalent to 125. Then we have x squared to the power of 3. So what are we going to do here? We are going to multiply the powers together to give us x to the power of 6. Then on the denominator, we have 3 cubed, which is equal to 27. Then we have y cubed all to the power of 3. So once again, we're just going to multiply the two powers together. So we get y to the power of 9. So now our final answer is 125 x to the power of 6, all divided by 27 y to the power of 9. Question 6. Simplify 3xy squared times 2x squared y cubed all to the power of 4. Okay, so here we have 3xy squared multiplied by 2x squared y cubed, all being risen to the power of 4. Now, just to make our lives a little bit easier, the first thing that we're going to do with this particular question is actually apply this power of 4 to everything inside of this product here. So in other words, we're going to apply this power of 4 to the 2, to the x squared, and to the y cubed. So what we now have is 3xy squared multiplied by 2 to the power of 4, and then x squared to the power of 4, and then y cubed to the power of 4. The 3xy squared can just stay as it is for now. 2 to the power of 4 is 16. X squared all to the power of 4, we're just going to times the two powers together to give us x to the power of 8. And then for the y, again, we're just going to times the two powers together to give us y to the power of 12. Now let's separate everything out into their groups. So for the regular coefficients, we have 3 and 16. For the x's, we've got x and x to the power of 8. And then for the y's, we've got y to the power of 2 and y to the power of 12. Now let's simplify. 3 by 16 is 48. X to the power of 1 times x to the power of 8, we're going to add the powers to give us x to the power of 9. And then for the y's, we've got y to the power of 2 times y to the power of 12. So once again, we are going to add the powers to give us y to the power of 14. So our final answer, 48 x to the power of 9, y to the power of 14. Question 7. Simplify 10x squared y cubed z to the power of 4, all being risen to the power of 2, divided by negative 4xyz squared, all being risen to the power of 3. Alrighty, so the expression that we're working with here is 10x squared y cubed z to the power of 4, all being risen to the power of 2, all divided by negative 4xyz squared, all being risen to the power of 3. So, first thing that we're going to do here is apply both of these powers of 2 and 3 to everything inside of these products. So for the numerator, we'll apply the power of 2 to the 10, to the x squared, to the y cubed, and to the z to the power of 4. On the denominator, we're going to apply this power of 3 to the negative 4, to the x, to the y, and then to the z squared. So then we end up with the following. Now let's simplify. 10 squared is 100. X squared, all being risen to the power of 2, is x to the power of 4. Y to the power of 3 to the power of 2 is y to the power of 6. And then z to the power of 4 to the power of 2 is z to the power of 8. Then for the denominator, negative 4 to the power of 3 is negative 64. X to the power of 3 is just x to the power of 3. Y to the power of 3 is just y to the power of 3. And then z squared all to the power of 3 is z to the power of 6. Now let's start splitting everything up. So for the regular coefficients, we've got 100 over negative 64. For the x's, we've got x to the power of 4 over x to the power of 3. Then we have y to the power of 6 over y to the power of 3. And then we have z to the power of 8 over z to the power of 6. Now, 100 over negative 64, by dividing both the numerator and the denominator by 4, we end up with negative 25 over 16. x to the power of 4 over x to the power of 3. Here we're going to subtract the powers, so we're going to have x to the power of 1. Similarly with the y's, so we're going to have y to the power of 6 take 3, which is y to the power of 3. And then finally, we're going to have z to the power of 8 minus 6, or in other words, z to the power of 2. Now, let's just write this in a nice compact way. So we're going to have negative 25 x y cubed z to the power of 2 all over 16. Question 8. Write with a prime number base. 27 to the power of x times 9 to the power of 4x take 1 all over 3 to the power of x all to the power of 2. Okay, so the fraction that we're working with here is the following. 27 to the power of x multiplied by 9 to the power of 4x take 1 all over 3 to the power of x all to the power of 2. Now, let's reread the question very, very carefully. Write with a prime number base. Now, what this is effectively asking us to do is to write this in the format of a to the power of k, where this thing here must be a prime number. Now, if we have a look at the three factors that we've got here, we've got 27 to the power of x, 9 to the power of 4x take 1, and 3 to the power of x all to the power of 2. Well, we know that a common prime number factor of 27, 9, and 3 is 3, because we can rewrite 27 as 3 to the power of 3. So that first factor there is now 3 to the power of 3 all to the power of x. 9 is 3 to the power of 2. So we now have 3 to the power of 2 all to the power of 4x take 1. And then the denominator, the base is already 3, so we can just leave that as it is. Now that all three of these bases are the exact same prime number, let's now just go about and simplify. So 3 to the power of 3 to the power of x, well, that's just going to be 3 to the power of 3x by timesing these two powers together. Then we have 3 to the power of 8x take 2, and that is once again by multiplying these two powers together, all over 3 to the power of 2x. Again, we just multiplied those two powers together. Now, on the numerator, we are timesing the same base, so we're going to add the powers. So this is now going to be 3 to the power of 3x plus 8x take 2, all over 3 to the power of 2x. And then by simplifying the numerator, we get 3 to the power of 11x take 2. Now we are dividing the same base, so what we're going to do here is we're going to write 3 to the power of this power minus this power. So 11x minus 2 minus 2x, which simplifies into 3 to the power of 9x take 2. So we know that this is going to be our final answer, since this number here is a prime number base, and we've got in the form of that prime number to the power of something. In this case, 9x minus 2.